I get a lot of questions about how to run a successful crossover research program where we're taking work happening in the field and connecting it with work in a genetics lab. Sometimes the questions are coming from ecologists who are a little bit intimidated by all of the sort of specific lab techniques that they may not have had any training in how to do. Sometimes the questions are coming from geneticists who want to use their skills and talents to make a difference in conservation and the environment, but aren't really sure how well their hyper-specialized molecular techniques sort of gonna connect to wildlife biology, where you have to learn to expect the unexpected. My advice is always to focus on the basic techniques that we're using all the time, that are totally indispensable in this kind of lab. If you start at the very beginning and think just about how we extract DNA from the variety of sources of material that we're working with, from blood and hair and tissue, what are the techniques that you really need to get right? And what are the most common mistakes that people make that can ruin a project before it even gets started? Even little minor mistakes that have almost no consequence when you're dealing with a super optimized model system can get amplified when you're dealing with environmental DNA and wildlife, and you might not discover them until it's too late. When I see someone getting these 3 things right, I know right away that they're going to succeed. So what I'm going to do is I'm going to show you these 3 simple steps, and I'm going to go through them from the most common mistakes that I see happening in the lab to the most critical. If we're just talking about extracting DNA, if we're just talking about those critical first steps to the connection between the field and the lab, can you guess what these techniques are? Okay, so the first most critical step is almost so simple that some of you are going to wonder why I'm even talking about it. It's literally just how we open and close tubes. We are constantly opening and closing tubes, and there's a right way to do it, and there's a way that can really ruin your program. The right way is to sort of go very gradually, slowly, with good grip on the lid, just lift it off of the tube. One of the things that I see people do all the time, whether they're new in a lab or experienced and just trying to show how fast they can go, they flick that lid off and it makes that popping sound, and that popping sound feels so satisfying. But what it's also doing is it's also creating air currents and little droplets of liquid that are flying all over your bench space and potentially going to contaminate things, getting on your gloves and so on. You can do this with 2 hands, the way we're seeing in one video, or you can use a test tube rack on the bench to help you provide provide you with some grip so that you can sort of open the tube lid carefully that way. Okay, so the second technique for how you open and close tubes correctly or not has to do with screw cap tubes, the kinds of tubes that many of your samples will come in if they've been shipped, or little reagent tubes. And I listen to people talking all the time about whether or not it's appropriate to put the lid face up or face down on the bench, whether you should have a paper towel there to put the lid on or not. And people who have all of the experience they need to succeed will appreciate that there's a third choice. It's not whether or not you put the lid face up or face down, it's whether or not you put the lid down at all. And so one of the techniques that I encourage people to practice and train on is just holding that lid in their fingers so that they're not putting it down on the bench at all. This is proper sterile technique, just moving the lid back and forth between your fingers and the tube quickly and smoothly as possible. Okay, so the second step that we're always asked to do is mix liquids together. So step number 2, mixing liquids correctly. And there's 2 common ways that we're asked to do this. The first technique involves using a vortex. And people use vortexes all the time in genetics labs. They're very familiar. But this is another area where technique tends to break down. Okay, so think about how a vortex works. It works by swirling liquid around. It needs to be able to do that vigorously for a couple of seconds to succeed. The 2 mistakes that I see people make all the time are they just go bzz, bzz. They just do it for half a second and the liquid barely starts to move. The other mistake that I tend to see is people putting a tube on a vortex for an awkwardly, uncomfortably long period of time. They're just sort of sitting there holding it. Sometimes those are people who are a little bit overconfident, going too quickly. Sometimes those are people who are a little bit anxious or nervous to be stepping into a lab maybe for the first time and just wanting to get it right. But the people with the experience to succeed, you'll notice, have the tube on the vortex for an appropriate, comfortable amount of time, maybe 3 to 5 seconds, just like you see in this video. The second way that we're asked to mix liquids all the time in these kinds of protocols is to mix by pipetting. And this is where you want to be maybe a little bit more gentle, rapid, but not rushing in your mixture. And this is an area where I see techniques break down. What happens is people become overconfident. Maybe they're trying to show how quickly they can get through a procedure. Maybe they're losing a little bit of focus. But this is where simple, basic pipetting technique goes out the window for many people. Rather than pipetting up and down slowly, carefully, you see them go pop, 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 pop. They're moving the pipette in ways that they wouldn't normally. The right way to mix by pipetting is to keep good pipette technique, drawing that liquid up gradually, slowly, carefully, and expelling it smoothly, and doing that maybe 3 to 5 times. Not just once. When people rush, I see them do it just once, up and down, really quick. And again, not an awkwardly uncomfortable, very high number of mixes. You just want to do a good, smooth 3 to 5 mixes with a pipette. So we're working through the 3 steps that I've seen over the years make the difference between a successful and a challenging crossover between a field and a lab scientist. And the most common mistakes have to do with the simple, basic techniques of opening and closing lids. The most underappreciated ones tend to be how important it is to mix samples correctly. Now we're reaching the most critical one. All modern DNA extraction techniques work by allowing us to separate the DNA that we want from mixtures of waste, whether they're semi-solid wastes or liquid wastes. The first technique that we're often asked to do is discard flow-through. Now, flow-through in modern DNA extractions is the liquid that comes through a filter and ends up in the bottom of a tube, and you just got to get rid of that. So the phrase discard the flow-through tells you right away that your flow-through has the waste and you want to get rid of it, and your DNA is somewhere else, probably stuck to a filter somewhere or in a separate tube. There's a right way and a wrong way to do this. One of the most common wrong ways to do this is to forget where your DNA is and discard the DNA instead of the waste flow through. So gently, carefully, smoothly, you separate the filter from the liquid and you can just dump it. You don't have to get that bottom tube totally dry. You don't have to use a pipette to carefully suck up all of that liquid and expel it. You just have to have a beaker or flask for waste and gently empty it. Just let the volume flow out and replace the filter. There are other times where you need to manually separate your DNA from the waste by pipetting the DNA. This is the most critical step in any DNA extraction, and it's the one that I see people mess up far too frequently. When you're asked to pipette the supernatant, that's telling you that the DNA is in the supernatant and your waste is in the junk at the bottom of the tube. Sometimes the mixture that you're asked to pipette will be pretty clear and you won't see much of a pellet at the bottom of the tube. You just pipette what you're asked to pipette, the volume you're asked to pipette, and you try not to scrape the bottom of the barrel. You don't want to disturb any pellet, no matter how small it is, that might be at the bottom. But when you're working with environmental samples, you're often going to get mixtures that are very goopy, thick, dark, hard to see, with lots of debris in there. And you still have to find a way to separate liquid from the junk that you're supposed to leave behind. And that's hard. Many people make the mistake of assuming that the DNA extraction is asking you for a specific volume to pipette because that's what you need to succeed. But that's not quite right. What a better interpretation would be is to understand that you're being asked to take up to that volume of liquid out of the tube and carry it forward in your extraction. And you can do that very easily when you're working with a clear liquid But when you're trying to separate a lot of debris from that liquid, you need to work on the principle that less is more. Leave behind liquid that you can't readily separate from the debris. If you're going to be able to separate the supernatant effectively from all of the waste that you're supposed to discard, you need to prepare that sample properly, and you need to do it to ensure that you're getting good lysis and that your DNA is available to separate from all of the waste. And that's why we emphasize so much in this lab and on this channel the importance of getting good DNA samples collected in the first place. We have other videos for how to do that.